So I'd like to talk about what happens when two quantities are inversely proportional to each other. As a quick recap, when we looked at direct proportion, we said y is proportional to x, or whatever each of the quantities are. It could be z and t squared, it doesn't matter. That proportionality symbol can be replaced with equals k. So that gives us y equals kx, where k is the constant of proportionality. Now, if you think about the graph of this relationship, thinking back to y equals mx plus c, we know there is no y-intercept. So that's going to give us a straight line running through the origin. The difference here is that the gradient is equal to the constant of proportionality. Now, when we're talking about inverse proportion, rather than as one quantity increases, so does the other, what it actually means is as one quantity increases, the other goes down. So, for example, that might be the distance travelled and the amount of petrol left in the tank. Distance driven, even. Distance driven and amount of petrol in the tank. As one goes up, the other goes down. Now, if we're thinking about how we can actually represent this algebraically, what we say is we say y is proportional to the inverse, the reciprocal of x. Other than that, it remains very, very similar, because that proportionality symbol can still be replaced as an equals k. But what we've got is we've got equals k times 1 over x. Now, if we're thinking equals k times 1 over x, and you think about your fraction multiplication, that's the same thing as having k over 1. And so when I multiply it, I've got y equals k times 1 is k, over 1 times x is x. So that is how that relationship will look. In terms of a graph, what you would have is you'd have y and x, and it will be a reciprocal graph, which makes sense because we've got a reciprocal there. Now, what I'd like to do is I'd like to start to do an example for you. I'm going to go straight onto a worded example, because I think having practiced the direct proportion and having done the direct proportional examples, I think it's worth just going straight into a worded example. So let me move that across. It's quite a long wordy one. It says, the force of attraction F between two magnets is inversely proportional to the square of the distance between them. Now, at this point, I stop, because that's the statement that's telling me about the proportion. And if you recall, what I suggested that we do is we underline things we need. So the force of attraction F, I've gone too far. The force of attraction F between two magnets, so that's F. Then we've got is inversely proportional to. So that bit there, I'm going to underline all of that. And I put the proportionality symbol there and 1 over, because it's inversely proportional to. So I'm talking about the reciprocal or the inverse that I'm dealing with. And then we'll carry on underlining the square of the distance between them. Right, I'm going to call the distance d, so that's going to be d squared. Then I look back at that sentence and I can see that actually I've underlined it all. I've made sure I've got all of the important information. I've spotted it's inversely proportional. I've spotted it was the square of the distance. Those are all really important facts. Other than that, it doesn't change from what we've done previously. So we start off by saying, therefore, F equals K over d squared. And the first thing I have to do is find d. So f equals 18 when d equals 2. So that's going to give me 18 equals k over 2 squared. 2 squared is 4. So that's going to give me that k is 18 times 4 because I'm going to multiply it across. And that's going to give me that 72 is equal to k. So I can say f equals 72 over d squared. Then I'm going to look back at the rest of the question. And I'm going to say that for part A, what is the force of attraction when the magnets are 6 centimetres apart? So F is what? When D equals 6. Well, that's going to give me F equals 72 over 6 squared. 6 squared is 36. Apologies. You just move the camera back. F equals 72 over 6 squared. 6 squared is 36, so I've got 72 divided by 36, 2 newtons. Then I've got for part B, I want to find, it says how far apart are the magnets, so I'm finding D when the force of attraction is 8. So that means I'm saying 8 is equal to 72 over D squared, which rearranging that will give me D squared is 72 divided by 8, which is 9, and I've run out of space. So that's going to give me D equals 3. So they're going to be 3 centimetres apart. Apologies for the squash at the end. Okay, please remember that you should actually write it underneath and have one equal sign on each line. So there's not really much difference from direct proportion. You have a little bit more algebra to deal with, but the actual technique stays the same. You find your constant of proportionality, you substitute the values in, and then you solve the equations.